All right. Good morning and good afternoon, Patho. I hope everyone had a good 4-day break, got some rest, got some stuff done on your book, got ahead in all your other assignments. All right. So, that being said, let's go and talk a little bit more about infectious diseases. Influenza. Now, let me uh, let me give you a little warning. You're gonna hear a lot of numbers in this one. Don't get concerned. Okay. My main thing is I'm laying out for you influenza. However, I don't necessarily need you to remember the numbers. Just remember the content. Okay. So you're going to hear a lot of numbers and we'll talk about it, but don't freak out. Okay. Um, there are four types of influenza strains. There's A, B, C, and D. The ones we're most common, the one we're most familiar with are A and B. um, Typically A's are the ones that cause seasonal pandemics. Um, B, we'll talk more about this here in a little bit. B's typically do not. And I said typically, there's always a caveat to that, okay? Once again, influenza A viruses are the only influenza viruses known to cause flu pandemics. And when we talk about Spanish flu, that was A. When we talk about H1N1, that's A. We'll talk more about that. Influenza Z infections cause mild illnesses, but have never been linked to a epidemic or pandemic due to flu. Okay, it may make you sick, but it's not as lethal, and it's not as just debilitating as A and B are on your body. Okay, you'll feel a little bad, feel a little sick, get over it. Okay. Influenza D primarily only affect cattle, and there's been no recorded cases of D infecting humans. Okay, up to this point. There are 198 different influenza A subtypes. That's just A. Okay. um, Current subtypes of influenza A viruses that routinely circulate given in any given season are H1N1, the swine flu, and H3N2. Okay, and we'll talk more about that here momentarily. H1N1, it was thought to believe, at least the 2009 outbreak was thought to have occurred on a pig farm down in Mexico. Infected pigs with influenza A. Uh, you know, the farmers infected them. They passed it on to other people, and that's what started the epidemic of 2009 of H1N1. Influenza A viruses are further classified into subtypes. Okay, so you have classification and we have the subtype. Now, B's are different. B's are classified into, it's called lineages, and we have two lineages for B. We have one which is known as Yamagata, and we have the other one which is known as B Victoria. Okay, so remember, B's are linked into lineages, not subtypes. Okay. Both influenza A and B can be further classified into specific groups and or subgroups. When we say H1N1, what exactly does that mean? So you have two things. You have the hemagglutinin and the neuraminidase proteins. And when a new flu strain comes about, basically think of it as a clothing rack. You wake up every morning, you walk over to your closet, you grab a shirt, you grab a pair of pants or a pair of shorts, you put them on. That's pretty much what influenza does as well. When a new strain of influenza develops, they pick how many hemagglutinin proteins and how many neuraminidase proteins that they have. Um, so that's what this means. So when we say H1N1, it's saying that has one hemagglutinin protein and one neuraminidase protein. Okay. And basically what these proteins do is they're little protein spikes on the surface of the virus, which help it invade the cell. Okay, so that if you have, 101, then that's all it has. If it has 18 and 11, okay, there are 18 versions of hemagglutinin and 11 for neuraminidase. So you can literally have H18 and 11, okay? H-flu picks out one style from the NRAC and another from the HRAC. The new bird flu in China is classified as H7N9. It covers itself in 7 H's and 9 N's. Okay, while H1N1 is a bit more low key and goes only for style 1 from each. Okay, all told, there are 98 different subtypes of influenza A, from H1N1 to H9N16. Let's see here. H1N1 is one of the most promiscuous, meaning that it can affect all sorts of different people. It can affect birds, people, pigs, and horses. Okay, where others can only specifically attack certain animals, certain living beings. Not H1N1. H1N1 can attack so many different other things. And H1N1 is also the ancestor to the Spanish flu. Here's a good little Venn diagram of all the different forms of influenza strains and exactly who they're infectious to. So we see H1N1 right here, and that is infectious to both pigs and humans. Okay, we have H5N1, which is bird flu, and that's infectious to birds, pigs, humans. Okay, we even down here we have H17, which is infectious to bats, seals. Influenza in seals has been found. All right. So this is, like I said, this is a good schematic to look and see really what strain of influenza is infectious to humans and birds and pigs. Now, with bird flu, you may hear it known as bird flu. You may also hear it known as the avian flu. Okay, it's the same thing. H1N1 swine flu has undergone relatively small genetic changes to their genetic makeup, pretty much. The properties in the virus that affect immunity. This is when I said this is what caused the 1918 Spanish flu outbreak. It was the H1N1 with genes in the avian origin. So basically, it was H1N1, but it began as avian flu, converted over to swine flu, converted over into humans. Okay, this is influenza. This is how this thing mutates. That's why it's so hard for us to get a gauge on what strain of flu we're going to see this year. This is how we make predictions on vaccines, and that's why no flu vaccine is 100%. It's a guessing game. Think of it as meteorology. Okay, you watch the news, you see the weather forecast, or you look at your app on your phone and you see a weather forecast. That is a forecast. That's what they believe based off of scientific data that they're looking at and specific weather patterns. What the weather is going to be like here in Keller on Thursday. Sometimes they're right, sometimes they're wrong. We see this definitely in Texas more along the lines of wintertime when they say, yeah, we can get like a little, spattering of snow. And you wake up in the morning and we have 16 inches of snow on the ground, which happened back in 2009, 2008, something like that, where they're saying, now we may get 1 to 2 inches of snow. Wake up, literally, I had 18 inches of snow in my front yard. So they're off that day. Well, same with influenza. Sometimes they're on, sometimes they're off. 9 times out of 10, they're off because there are so many different strains of flu, and it's hard to really predict which strain we're going to see this year. H3N2 swine flu, of all the influenza viruses that routinely circulate and cause illness in people, influenza A3N2 swine flu virus tends to change more rapidly. Okay. This is the fastest mutating one out of all. Okay. Now, you look, we have H1N1 swine flu, H3N2 swine flu. They're both swine flus. Okay. It just means how many hemagglutinins and how many neuraminidase proteins we have. Okay. H5N1, also known as bird flu or avian flu, is a very lethal strain of influenza. We see this definitely in the wet markets. Over in China, we have wet markets where you can actually, once again, you can buy a live animal, they kill it for you, they defeather it, they process it for you, and you take it home with you. Wet markets have been widely believed to be the part of the outbreak problem of COVID, is due to wet markets. And we see this with bird flu as well. So wet markets are definitely a cause for concern. The dominant strain of the dominant strain of flu, this is which was last year, was H3N2. Usually leads to more serious symptoms and hospitalizations compared with H1N1. 2018's flu season saw the dominant strain flip from H1N1 to H3N2 around March of 2019. So we had the influenza outbreak in 2018, which was really bad. I know some people that have loved ones that were really impacted and infected by by flu that year. And we saw that it started out as H1N1 and flipped to H3N2. Okay, and we'll talk about flipping here in a second. Here's a little diagram about regarding how we actually get swine flu. Typically, it's going to start out in birds on the farm, transfers over to swines. They breathe in vapors and stuff from the birds. Pigs get it. Farmers farming the pigs are exposed to it by either inhaling the flu virus from the pigs, handling the pigs, touching their face, not washing their hands in between. But you cannot get it from eating pork. Okay, so bacon is still safe to eat. So don't go freaking out saying you can't have any more bacon because of influenza. And then of course we spread it to one another. 2011, a specific H3N2 virus was detected with genes from the avian, swine, and human viruses. And a 2009 H1N1 pandemic versus the M gene. The virus was circulating in pigs in 2010 and was first detected in 2011. Once again, this one, the 2009, started. It's believed it started on a pig farm down in Mexico, and then jumped up to the United States. Here's another little diagram of how we can get swine flu, and of course transfer it on to others. Once again, handling the pig, it's on, the farmer has it on his hands. He touches his face, he inhales the influenza, and it goes on from there. From direct contact and also from surface contact. We have the pig drinking water out of their little water bin here. The farmer goes and handles the water bin, then touches their face, and then touches the food dispenser here, and then it passes back into the pigs. All right, so you gotta understand how this works. So they get it directly from the pig here. It goes to humans. Humans can actually spread it back into pigs. Okay. What I'm saying here is this. We can get it from pigs. It's in our body. It mutates every time it goes into a new host. The influenza has the opportunity to mutate. If it mutates, then we pass it back on to the pig, and now they have a different strain than what they passed on to us. Does that make sense? So this is why flu is so difficult, because once again, it mutates at such a rapid pace. Here's the avian flu. Many epidemiologists believe that this is how the next big pandemic is going to start. Now, even with COVID out there, many scientists, many epidemiologists and virologists do not believe that COVID, this is the big one. There's not a lot of proof among virologists that this is what they believe. They don't believe this. They believe there's something bigger and badder out there, and it's only a matter of time. Okay. But what many of them do believe, that it's going to come from avian flu. Okay. Infection of type A virus, H5N5, avian or bird flu. Most virulent bird flu virus, mutates rapidly, altering its genetic materials. Humans infected by close contact with live infected poultry. You see them handling the chicken here. They get it. Remember, it's respiratory, it's airborne. So anytime you're handling this, you handle the chicken, you touch your face, you're breathing that in. The chicken is breathing, you're breathing that in as well. Birds carry viruses and excrete it in feces, which dries, becomes pulverized, and then can be inhaled or taken in by touch. Once again, it's basically dried poop that over time will get pulverized into the ground. It mixes in with the dirt, and you're breathing that in. Humans have no immunity against this virus. That's the scary part. Let me go back to that. Once again, humans have no immunity against this. Okay. This is the reason for concern. Humans infected with bird flu could serve as a host for a new genetic subtype that can be transmitted from person to person. When left untreated, rapid deterioration, viral pneumonia leading to respiratory distress, kidney failure, multi-organ system failure, and then death. This is what many scientists believe is the big one. All right, and that's why wet markets, they're looking, they do so much research in the wet markets, and to see how wet markets play a role, how could wet markets play a role in the next big influenza outbreak. This is another schematic here looking at just the different strains of flu throughout the 19th and 20th and 21st century here. So we have the Spanish flu, 1918, H1N1 variation. And then later on, we see another Asian flu outbreak, H1N1. Then it goes into H2N2. Then we go on, and then in 2006, we see H5N5, the bird flu. And then 2012, we see the swine flu. All right. This is a good indicator of how influenza mutates. So in this first column, we have H1N1, okay? Bird to human transmission, H1N1. Directly from the bird into the human. This is what it looks like right down here, okay? All these segments, it's the same one, okay? Here's where we start mutating. If you look at the 1957 Asian influenza, we had H2N2, meaning you had exposure to a new strain of influenza, and those segments from that new strain reassort and mix with the H1N1, and so now we have 3 strains of this new one. Okay. Once again, that new one then comes in contact with another new strain of influenza, H3N2, and takes segments from that and combines it. So now we have Five from the original, one from the one we just mutated from, and now this new avian flu. And we get two from that. Jump over. Now this one comes in contact with another new avian flu virus. And then it mutates. This is how it's going to keep going and going and going. Okay, this is why many epidemiologists and virologists believe that this is going to be the next main pandemic. Not COVID, but some sort of H5N1 variation of influenza, of which we have no immunity against. Now, in 2019, we saw something different. We saw that the main strain of influenza, and if you got the flu last year, chances are you had influenza B, the Victoria lineage. And that was odd because typically we don't see bees having a huge epidemic impact. B Victoria viruses appear to be the most common strain affecting individuals under the age of 25, while influenza A, H1N1 viruses are more commonly reported among individuals 25 and older. So B impacted younger people more than A did. 70% of influenza-associated hospitalizations among children were ages 18 to 27. Here's how we know if you're actually had the flu or battling a cold. If you have a sudden onset of fever, like you're sitting there at school, all of a sudden you just really don't feel well. You start getting that, with me, my hands get cold. If my hands start to get really cold, I know I'm running a fever. So if you're sitting there or you start to get chills or you just don't, it just hits you and you just don't feel good, chances are it's influenza. A common cold is normally a gradual buildup. Wake up and not feeling all that great. May have a runny nose, something like that. Next day, still not feeling great. Just feel a little sluggish. May now have a little cough. But influenza hits very abrupt. Chills are extremely common. Sometimes you get the head part of it. Sometimes you get sneezing, runny nose, stuff like this, stuffy nose. Sometimes you don't. You definitely have body aches with influenza. With the common cold, body aches are for the most part rare. You may just not feel good, but your body just doesn't completely ache like it does with influenza. AIDS and HIV. What is HIV? HIV is human immunodeficiency virus. It attacks the cells that help the body fight off infection. So basically, it attacks the cells that help you stay healthy. So because what happens is those lymphocytes, the CD4 cells, they start fighting off infection. Well, with AIDS or HIV, it attacks those and destroys those. So now your body is able to become infected by all sorts of different things. That's why most people, when they have HIV, they don't die of AIDS. They die of typically pneumonia or something like that because their body can't fight it off because they have no more T cells or CD4 cells left. HIV is a virus spread through certain body fluids that attacks the body's immune system, specifically the CD4 cells, often called T cells. Over time, HIV can destroy so many of these cells that the body can't fight off infectious diseases. Left untreated, HIV reduces the number of CD4 cells in the body. This damage to the immune system makes it harder and harder for the body to fight off infections and other opportunistic infections. So what we see with HIV is your body starts to lose those CD4 cells, and you basically become immunocompromised at that point. Your body has the inability to fight off other infections. And so you just, everything that you come in contact with, you get because you can't fight it off. And we call these opportunistic infections because you got it because you don't have an immune system left, pretty much. AIDS is the late stage of HIV. Um, and we see people living with HIV. We see Magic Johnson, we see Charlie Sheen. More people are living with HIV and it's not converting into AIDS. Okay. Like I said, Magic Johnson, he was diagnosed with HIV in like 1990, 91, something like that. So what we're going on 30 years, and he has not progressed into AIDS. Where did HIV come from? HIV came from the jungles of Africa. More likely, it was a bushman who came in contact with the infected blood from a monkey that he was butchering. The bushmeat market in Africa is very, very prevalent. And what this means is you have hunters going out into the jungles of Africa, and they're catching primates and they're killing them and selling the meat. Well, chances are what happened was this bushman, he was chopping up a monkey. He probably nicked himself. He was bleeding. He had an open sore, probably in his hand, on his arm, something like that. And the HIV from the monkey got into the sore and became infected, and infected the butcher. Scientists identified a type of chimpanzee in Central Africa as the source of HIV infections in humans. They believe that the chimpanzee version of immunodeficiency virus, also known as simian immunodeficiency virus, or SIV, most likely was transmitted to humans and mutated into HIV when humans hunted these chimpanzees for meat and came in contact with their infected blood. Okay, it was believed that for many years that the rhesus macaque monkey was the natural host. It is not. It is the Sudi magnabe monkey. It has HIV but no AIDS. This has HIV and AIDS. Okay, this was all gathered through genome sequencing. Scientists now say that the simian SIV, simian immunodeficiency virus in chimpanzees, which is believed to have been transmitted to humans to become HIV-1, the virus didn't cause AIDS, didn't start in its life cycle in chimps. So what they saw, originally what they believed was chimpanzees was the natural host. Come to find out through gene sequencing, it was not chimpanzees. Okay, instead it was a product of a separate virus, excuse me, jumping from different monkey species into chimps, where they recombined to form a hybrid virus, according to a new study. So let me break that down for you. You had HIV, or you had simian immunodeficiency virus in one type of monkey. Okay, that monkey came in contact with another monkey, passed it on. From there, it mutated. That new infection from that new mutated strain comes in contact with another monkey, get it, and it mutates. Okay, so once again, just like influenza, HIV, that's the problem. Part of the problem with HIV is why it's so hard to get a cure, because the rate of mutation in it is extremely high. Researchers believe the chimpanzee virus is a hybrid of the SIVs infecting two different monkeys, the red cave magnabe and the greater spot-nosed monkey. Chimps, and the other thing is this, chimps eat other monkeys. I know they're cute at the zoo and everything. You understand, chimps are a predator in the wild, and they eat other monkeys. And what they believe happened is chimps ate a monkey that was infected with SIV and developed this new hybrid virus. And this new hybrid virus then spread through the chimpanzee species and was later transmitted to humans, becoming HIV-1. Excuse me. An international team of geneticists and microbiologists looking at the initial AIDS outbreak in the United States saw that what was happening was that it did not start in LA or San Francisco. It started much earlier. They believed honestly that it started in New York in the late 60s, early 70s, because what they're finding was, on average, it took about 10 years for an infected person to show signs and symptoms. So if those patients are going into the doctor in 1980, 1981, chances are they got it in around 1970, 1971, 72. When you look at the different strains, and you look at that original strain, what they were finding was that it resembled the strains coming up from the Caribbean and Haiti. And then it landed, and then it came over to the United States. All right. So based on genetic heritage analysis, it showed that the San Francisco strain and the New York strain resemble that from the Caribbean. HIV arrived in New York precisely 10 years before doctors first noticed the disease in LA and San Francisco. The virus passed from the Caribbean to New York in the early 70s, where the disease gained a foothold for at least half a decade before triggering outbreaks in places like San Francisco. What we need to understand is the culture. This is a picture of Studio 54, iconic disco in New York in the 70s. Basically, what was here was anything and everything you wanted. If you were gay and you wanted to meet other gay men and have sex, you can meet at Studio 54. If you're straight and you wanted to meet other women or men for sex, you met at Studio 54. You wanted drugs, every drug was there available at Studio 54. It was an environment that was pretty much accepting of everything. And this was how society was in New York in the 70s. And this is what helped gave rise to the HIV outbreak, which would later start taking a foothold in San Francisco and LA. HIV-1 subtype B successfully emerged out of Africa sometime in the late 1960s and made its way to the Caribbean by 1967. A Haitian HIV strain from 1969 is the closest relative to those that first dropped in New York, suggesting it may have been the source of America's outbreak. However, this virus had been circulating among Haiti, Dominican Republic, Jamaica, Trinidad and Tobago, and Haitian immigrants, making it difficult to pin a single Caribbean nation, meaning that basically this strain was basically going back and forth between all those countries: Jamaica, Dominican Republic, Trinidad, Haiti. And so it's hard for scientists to trigger, oh, it's from Haiti or it's from Jamaica. Okay. We just call it the Caribbean because it was infecting everyone in that area. So let's look at this timeline real quick. So we have here in 1969 through 1974 in New York. Well, let's start down here. 1963, 1971, we have HIV in Haiti. Okay, came over from Africa. It starts here in Haiti for the Western Hemisphere. Okay, then from Haiti it goes up to New York. From New York it goes to New Jersey and Pennsylvania. Also from here in New York it goes down to Georgia. Okay, you see here different strains here in Georgia are linked back to the ones out of New York. Then you also have the strain all the way to California. This strain is also linked to the San Francisco outbreak. Okay, and if you look, it's also here. We see it, the pink here in New York. New York here in the 80s and or early 80s, late 1979. Okay, and then we have this strain also from New York that impacted Georgia as well. All right, so, oh my goodness, okay, there we go. All right, so with that, I'm going to stop there, and this will be on the Google site, so you can go check it out, and we will pick up there next time.